So now modulo multiplication identity, I alluded to this earlier as well. So the above concept of, quote, multiplying a number and its vortex sum result in the same vortex sum can be generalized as a modulo multiplication, quote, identity, or formula stating two sides are equal. That's just identical. Yeah, two sides are identical. Let's call it an identity. So since the vortex sum is the specific case of mod base minus 1, this is excluding the part where it's equal to 0, then you just set that equal to the base minus 1. So then we can write the following vortex sum example in its equivalent modulo notation. So for example, if we have number 25 like this, multiplied by 4, this is going to be, I'll just write it like this, times 4. This is 25 times 4 is just 100. You can just go 4 times 5 is 20, put a 2, 4 times 2 is 8, and then that's 8 plus 2 is 10. Or, just 25 is a quarter times 4 quarters is 100. So this is going to be v equals to 1, like that. Or you could go right here, v equals to 2 plus 5 equals to 7 times by 4. Yeah, so for smaller numbers like that, or for some special cases like this where it's all even, it's sometimes it's easier just doing the multiplying this 25 by 4 than getting the vortex sum. This is going to be, so then that's 7 multiplied by 4. We're going to have, 4 times 7, let's go times by 4 equals 2, or actually make it a bit more uniform. This equals to 7 times by 4 like that. This equals to, 28. And then v equals to 8 plus 2. Then this equals to 10. V equals to 1. Like that. So these are the same as expected. Like that. These are same. Yeah, or we could write these as, or you could just write these as 4 times 25. Remember, you can just get the mod function of it. Mod 9 is base 10. So mod 9. Again, if I don't specify which base, it's going to be base 10. So equals 2, this is going to be, 4 times, let's write this in as equivalent mod function, because that's the vortex sum, or that's the remainder, it gets 1, then 4 times 25, mod 9. So 25, the vortex sum of 25, over here is going to be 25 mod 9, so 4 times that, and then I'll put this all into a bracket like that. Mod P, or mod 9. Yeah, now here I just added the mod 9 there. So, and we could double check our results. We just go 4 times 25 mod 9, just using the built-in base 10 calculator here. So equals to 1 right there, mod 9, and as expected. And then if we go 4 times and then bracket 25 mod 9, close bracket mod 9 equals to 1. And so we can actually generalize this for any integer multiplication and for any modulus. So we could write this as a times b, capital B, mod c. So it doesn't need to be mod 9, just anything, because we're not taking the vortex sum here. We're just doing general modulo identity. This equals to a times b mod c. So the multiplication of these, the modulo of it, is equal to a times the modulo of b, or b relative to c. So b mod c, close bracket, mod c, like that. Or you could also do this way, because again, it's all multiples, and these just find the remainder when you're dividing by c as the modulus. So this is going to be the same as when you multiply a mod c. So if you multiply that instead, and this is going to be, or we multiply both, a mod c times b mod c, and this is going to be all mod c. Oops. Mod c. And in fact, you could do the other way around too, because again, multiples, doesn't matter which one you're modding. You can do mod the other way. You can go right here. This is going to be a mod c, and then times it by b. I guess times by b, close bracket, mod c, like that. Yeah, so that's what we have here, and we can see we could calculate this in an example just to illustrate this. So basically, if you have a number a equals to 11, b equals to 22, c equals to 7, so a different modulus right there instead of 9. So we'll have, let's say if we have 11 times, so 8 times b, or 11 times 22, then mod 7, that equals to 4. You just do this calculator equals 4, like that. That gets to, so this is this part right here. I mean, that's the first one right here. A times B mod C. That's the first one, and then, or you could also go 11 times this right here. So A times B mod C. So 11 times 22 mod 7, and then mod 7 of that entire thing equals that. The next one is multiply both, A times B, so 11 mod 7, or A mod C, and then times B mod C, or 22 mod 7, and then all of that mod 7 equals 4. Or you could go 11 mod 7, and then times 22, so A mod 7, or A mod C times B, then mod C, or 7, equals 4. So yeah, these are all the exact same thing. Yeah, and again, the reason is because these gives integers right here. So for example, if you have A times B mod C, now you could just apply the same identity to, like, the same one right here to this one, where now we multiply, we multiply this one. Or we consider that this A is being multiplied by this integer B mod C. These just give integers. So this can be considered as an integer. They're all integers. So that's the new integer that you're multiplying it by, or the new k. So k, and then this is going to be now a times k, like that. You can just take the a mod of this one. This is going to be our k, etc. And now you could apply the same thing here, or this one you can start from this one, and then the one that's k is going to be, well, this is going to be our k, like that. So as opposed to, so you could either, this one is considering this is a k, and then you get that. But anyways, yeah, it's pretty straightforward. Okay, I'll just delete that. So thus the modulo of a multiplication of integers is the same as the modulo of the multiplication of either or both modulo of the integers. Hashtag moduloception.